So once again, welcome everyone. Ale. So now we are going to talk the differential equation part. So last day basically talked about what is differential equation, ordinary differential equation, partial differential equation, etc., and how they arises in our daily life. And I said they arises from some change rate of change of some physical quantities or during some formulation of some physical problem or physical model. This can be in any physical model like in predator prey model, or you can assume any biological model such as malaria model, or everywhere there are differential equations are everywhere. So basically one thing which I have mentioned more and more, that was the unique thing of differential equation, that is existence and uniqueness of uh, solution of a differential equation. So today I'm going to uh, first let me share my screen. So once again I have to check that am I audible? শোনা যাচ্ছে?
Yes, sir.
Okay, okay, very good, very good.
Yes, sir.
Okay, so somehow this is a presentation, but somehow I haven't shown you the presentation because everything which is there in the slides actually I have written in the exam book. So I'm very sorry, but what can I do, because these are all slides. So I will share the slides and you will see uh, what are in the slides, because I have formulated, or there are some examples from where this differential equation arises, like such as Newton's law of cooling or swinging of a pendulum from this thing, and then order, linearity, homogeneity, and initial and boundary value problem. So I have mentioned initial value problem, but I have not mentioned the boundary value problem. So I will today mention the boundary value problem. So this is again linear, non-linear, this is such kind of things I have told you. So which terms can be linear and which terms can be non-linear, you can at once check, and from that check you can at once tell which differential equation is linear and which differential equation is non-linear. So if you see this non-linear differential equation should contain or may contain this type of terms, whereas this linear differential equation can contain this type of terms. So these things are there. So and linearity properties are there, and again life is mostly linear, or wherever some non-linearity arises, we just linearize it, or we make some assumptions for our purposes, and we solve, or we try to solve the differential equation I have told you, because it's very hard to actually solving non-linear equations, or even partial differential equations are very notorious kind of things. So these equations and this type of equations non-linearity occurs, and how do you actually linearize such kind of equations? Actually I am omitting this part, and homogeneous and non-homogeneous thing actually it's nothing, but if you have definite differential equation, there is something, if this differential equation has something in the right hand side. Okay, 1 minute, I have called. হ্যাঁ বলুন। কি কাগজ তৈরি করবো আমাকে তো বলো, আমি জানি না তো এটা। আপনি করেছেন বললেন তো। হ্যাঁ আমার কাছে আছে তো, আমার কাছে আছে আছে। So let me return to the original point where I was talking. So I think I was talking about this this homogeneous and non-homogeneous thing. So homogeneous differential equation is nothing, but where this differential equation has nothing in its right hand side, and non-homogeneous thing, there is some terms involved involving that t or but not exactly y. So t means this independent variable, and that exactly you have taken x. So this type of the terms containing x and some functions of x are there in the right hand side part of the differential equation. These kind of equations are called non-homogeneous differential equation. So this homogeneity part is, I think, is very clear. For example, if you check this type of equations is homogeneous, but if this thing is this zero is not there, it contains some function of t, then it becomes non-homogeneous. Okay. So once again, these are the examples of initial value problem. This first one is initial value problem, which I have told you that as a differential equation, first order differential equations, and this thing is mentioned. This is a example of initial value problem because the value of v is mentioned at some initial point. Initial point means some initial value of t or x, what you can take as, because in this slides I've seen that this t is taken in place of x as independent variable. So v, the value of the dependent variable v at 0 means the value of independent variable is 0, and the value of this v is v0. Okay, this kind of problem is called initial value problem, and second type of problem is this type of problem, second order problem, and the value of dependent variable is mentioned at both side, the beginning and the end, at 0 and L, at the value of x equals to 0 and x equals to L. This type of problems are called boundary value problem because the value of the independent variable for the endpoints, the value of the dependent variables are mentioned. So this kind of problem, if you see, this kind of problem is called boundary value problems. So these are the things, small things. This like initial value problems can be not only this first order, it can be of higher order also. This type of problems you see, these are initial value problems of second order. So again, you can see or you can check that this value of theta or the dependent variable is mentioned at 0. That means at the starting point. So this is called initial value problem. Okay. So now I'm just leaving this presentation and I'm going to give some interesting example. So first one, I can give you this type of example. Zero, five. So this is a differential equation. As you can see, this is actually it's a boundary value problem, and you can check that this problem has no solution. So the existence of solution of a boundary value problem is not also very easy. There are certain criteria of checking whether a boundary value problem has solution or not. Okay, so I think the solution of this equation, I think you can easily do that. So I think you all know this type of substitution, y equals to the power mx, and you can do the substitution and you can, I think, very easily can check the solution, and from the solution I think you will see, or you will get that there are two constants a and b. So that two constants should satisfy also these two equations. Y of 0 is equals to 1 and y of 5 is equals to 5. So if you from that these two relations you try to solve a and b, you will get nothing. So first try to solve, then you will see that you will get nothing. So there's no solution. So now again another, I can give you example. This is like dy dx equals to y by 3 1/3, and y of 0 is equals to 0. This kind of equations. This is again initial value problem. This is not a boundary value problem, but an initial value problem. And you can check that this f of x is 0, and f1 x 0, and f2x is equals to, I think this is 2/3 x to the power, I guess, 2 by 3. Someone has joined. So if you see these two solutions, this is a differential equation, initial value problem, and this, if you check these two, this f1x 0 and f2x 0, so these two are solutions. So this is a solution whenever x is greater than 0, and this is a solution whenever x is less than 0. Both, they are both solutions of initial value problem. So even this type of problem, there are many other solutions. So solution is not unique. So that's why you have to check whether there is one solution or more solution. Even I can give you some example like this thing. This type of problem. So if you check this kind of problem, you will see, so sorry, it's not 2 but it is x. So if you check this kind of problem, and if you apply existence and uniqueness theorem, that I have said that for the existence and uniqueness theorem we have to check two functions. One is f of xy, which is this function, and another is the derivative of this with respect to, that is the partial derivative of the function f. The partial derivative is nothing but a simple derivative, just is a function of two variables. You take the other variable as constant and do the derivative. So del f del y, if you derivative, it will become 1 by root x. It's simple. So you just take derivative with respect to y, taking partially, because you are taking x is constant, so root x will come. So 1 by root x will be there. So you see, you have to check the continuity of these two functions. So if these two functions are continuous, then existence and uniqueness theorem guarantees the existence and uniqueness of the solution. But you can see these two functions, there are these points of discontinuity or point of discontinuity, because if you see x equals to 0, this is the point of discontinuity. So there is no point of checking any solutions around 0. So this differential equation don't have a problem, do not have a solution around 0. So whenever you are doing with this kind of initial problem, so you are actually checking solutions at 0. So as I said that at x equals to 0 or around 0, there are no solutions of the differential equation. So you can if you have this kind of differential equation, so you don't really want to waste your time just by trying to solve this type of equations. So don't try, and because the existence and uniqueness theorem guarantees that this kind of problem don't have solution around 0. It might have solution in other part of the domain, but certainly this equation doesn't have any solution around 0. So this 2 or 3 points are important from the perspective of the last this lecture. So now I'm going to introduce the first order exact differential equation. first order exact ordinary differential equation. So we have this kind of differential equation, and let's assume, so you can write, or you can this function somehow we can manage in this way. It's very simple. For example, you have given a function dy dx is equals to, for example, you have x square plus y square by xy. You see, so you can just multiply, cross multiply, and you can see that y plus, or you can take it as minus, better. So see, this is nothing but mxy, and this is mxy, and this is nxy. So this is how we can write this kind of equation. So what about exact differential equation? So for exact differential equation, we need to know what is total differential. So total differential of a function is actually this thing, where df actually okay. So by exactness of a differential equation of this form, we mean there exists a function f such that del f del x, this is equals to m, and del f del y is equals to n. So if there exists a function, this kind of function, for which this del f del x is n m, and del f del y is n, we see, or we say that this kind of first order differential equation is exact differential equation. So you have to assure that there exists a function this. So exactly, it is very hard to show the existence of a function of this kind of function. So we'll make it easier by some theorem later on. But for the definition purpose, this is the definition, that there exists some function, that we have to show some existence of a function. Actually, this is the total differential, and you see this part you are writing it as m, and this part you are writing as n. So you have df is equals to m dx plus n dy. So actually you are writing this whole total differential equation as a total differential of some function f. So basically this thing becomes df. You see, this is m and this is n. So m dx n dy. So this, see m dx n dy. So I'm just omitting xy for some purpose. There's nothing involved there. So just omitting this thing, these notations, and yeah, I'm just using m in place of m of xy. So this is a very simple thing. Now what we can do, that you can see that del f del x is equals to m, and del f del y equals to n. So now if you try to check what is del m del y, is basically this, and if you want to check del n del x is equals to, basically you are just taking partial derivative of m with respect to y and n with respect to x. So now these two things might not be equal always, but for a very good continuous function, and which satisfies some criteria, as they are actually a theorem of Young's theorem or source theorem. So I can't tell you right now, but there are some criteria under which this can be equal. So actually we consider only those functions here in form of this total differential which satisfies such type of criteria, and we just make them equal. So this is exactly the condition for this becomes the condition for exactness of differential equation. So actually the criteria, just I can mention that what this is exactly continuity of first order partial derivative of f. So if you take the continuity of the first order derivative of f, so you will have these two things are equal. So then we have del m del y is equal to del n del x. So this is the condition of exactness of differential equation, and you see this condition is very easy. So you have m and you know n from this relation, and you just take partial derivative of m with respect to y and n with respect to f, and you check if they are equal. If they are equal, this equation is exact. So this is actually a theorem, actually a result. So why I am checking this is exact or not? There is a reason, because this exact differential equations are very easy to handle, because they are if you try to solve them, they are actually very easy to solve. So exact differential equations are a part of differential equation, part of ordinary differential equation, which are very easy to solve. Okay, so what is the solution of exact differential equation? So the solution is, this is again a result. So the solution is this f equals to c. So that f which I have talked about earlier, that f equals to c means a constant, where del f del x equals to m and del f del y is equals to n. So this f equals to c is the solution of the differential equation. This differential equation is, you can check this given differential equation m dx plus m dy is equals to 0. This given differential equation m dx plus n dy, this is the given differential equation, and the solution of this differential equation is f equals to constant. What is f? F is a total differential, where you know df is equals to actually that whole thing, and the coefficients, the del f del x is actually m, and del f del y is n. So such kind of function f is a solution of differential equation, and so I can give you an example like this type of example: 3x square plus 4xy plus dx, and 2x square plus 2y plus equals to 0. Such kind of equation, and you see at once this is m, this is n, and so if you check that this is m, so del m del y. What is del m del y? Del m del y will be 4x, and if you check del n del x, it will be again become 4x. You see, because del n del x is 4, because you are taking partial derivative, so this thing cancels and it become 4x. And again, why del m del y is 4x? Because you are taking a derivative where x is constant, so this term is 0, and from this term you will get 4x. So these things are equal, del m del y and del n del x. So this is an exact equation. And what about the solution? And I said the solution will be given by f equals to constant, where del f del x equals to m and del f del y is equals to n. So del f del x is equals to 3x square plus 4xy. You see, del f del x is equals to 3x square plus 4xy, and del f del y, if you check, this was I think 2x square plus 2y. So what is f? F is nothing but you take just take integration, and if you integrate this side, you will get x cube 2x square y, but and there will be a constant, but since this is a partial derivative, this constant will not be a perfect constant, but it will be a function of y, because here whenever you are talking about partial derivative with respect to x, you are treating y is constant. So this constant is not a particular is a perfect constant, but it will be a function of y, because any term which involves y as a function of y will get cancelled when you are taking the partial derivatives. So there this thing will come. So from this, if you try to find what is del f del y, you will get this becomes, you are checking what is del f del y. So this thing is cancel, this x cube part cancels, and we will get 2x square plus phi dash y. Phi dash is nothing but derivative of this thing with respect to y. So but you know, you have 2x square plus 2y is del f del y is known. So you have to have this phi dash y should be 2y, and from this you can at once check that this phi y should be y square plus constant. This constant is you can say d, and this is a perfect constant. So hence we have f is equals to x cube plus 2x square y plus you put the value of phi y, that is y square plus d. So this is your required function, and this function is equals to some constant is the solution of your differential equation. So if you check, the solution will be x cube plus 2x square y plus y square equals to k, this is the constant. You just remove this d to the left hand side, sorry, right hand side, and this constant and this constant they add or add subtract anyways, and we become another new constant, we limit it as k. So in this manner you can solve this kind of equation. So this is a method, and we have to know this method, and it will be or it will, you will face this type of method. You have to, you will be told to solve this kind of equations times and times. So just try to understand what I have done. So it's very simple, but first of all you have to have some idea on partial derivatives. Without this actually this kind of things are not possible. So actually partial derivatives, the idea which we needed here but are not that tough, is very easy. So we have to just know that what is meant by del f del x, and the partial derivative means whenever you are taking derivative with respect to one variable, you treat other as constant. This is that's all we require. Now I'm going to take some functions or this kind of equations, m dx plus n dy is equals to 0. So I'm going to talk about integrating factor. I think this name is quite familiar with you. So integrating factor means if you have an equation of this kind of form which is not exact. Not exact means you can't find those type of function f, or you can use the first theorem and this theorem and check that del m del y is not equals to del m del x. So this equation is not exact. So this kind of equations we have in your hand, and somehow some function which can be a function of x and y. So this type of functions you can multiply with this equation, and the equation we demand will be exact. This is an exact equation we demand. So nothing harm in it. So our new m dash will be mu m, and new n dash will be mu n. So this equation reduced to the equation m dash delta x plus n dash delta dy is equals to 0. This is our new equation where m dash or n dash are like that. So this is the integrating factor. So we have a non-exact equation, we can make it as exact. So before going into further into integrating factor, let me tell you that there are actually separable this type of things. This separable separable differential equations are like this kind of form: fx gy dx plus, you can say, fx gy dy is equals to 0. This is a special kind of differential equations. So this kind of differential equations, you can at once see that if you can rearrange this type of thing, you can at once you can integrate this thing, or you can say that mu, or that integrating factor, will be nothing but f of x g of y. That is, if you multiply this throughout this equation, this thing will multiply by this, and gy cancels out, and it will become fx by small fx dx, and this thing will become gy by capital Gy. So you see the x part and y part separates out. So, and you know what to do whenever you have only a function of x one side and only function of y other side. You just take integration, and that's how we can solve the equation. It's very easy. You just multiply this thing, and you see the next line, the very next line, it becomes this, and you just take integration. Sorry, this is not plus, but again this is again g of y, this. So it's very easy. You can integrate out, and you can in this way you can solve equations. So this is a separable equation as a particular part which we mentioned. So now I'm going into homogeneous equations. Homogeneous. So you have this kind of differential equation. So see, homogeneous function means you are given a function, see, fxy. It is called homogeneous if you replace x by tx and y by ty, and you just do some algebraic calculation, and if you get becomes t to the power n f of xy. So if this happens, then this kind of function is called homogeneous of degree n. For example, it's not very difficult. For example, if you see this kind of function f of xy is x by y, what you will do, you just replace x by tx and this, and now see t cancels out, and it becomes x by y, and it becomes actually t to the power 0 x f of xy. So this function is called homogeneous of degree 0. Another example I can tell you, this you can take this kind of example: f of xy is equals to x square plus y square. So you see, if you replace x by tx and y by ty, you see it becomes t square x square and it becomes t square y square, and if take t square common and it becomes t square x square plus y square, and this is exactly t square f of xy. So this is a homogeneous function of degree 2 because t square is coming out. So homogeneous equations means these functions m and n are homogeneous. So whenever they are homogeneous, this kind of function we say homogeneous function. Okay, so why I am talking about this homogeneous equation? So actually there is a result or theorem which tells you that if you are given some homogeneous function or homogeneous ODE, which is m dx plus n dy is equals to 0, and this type of equations, if you replace y equals to vx, this kind of thing I think you have done. So this kind of equations, if you replace this kind of y equals to vx, then this equation can be transferred to a separable equation. So an homogeneous equation, you have an homogeneous equation, and if you do this type of substitution y equals to vx, then these homogeneous equations can be transferred to a separable equation, and you know how to solve a separable equation because separable equations are for separable equation is very easy to find integrating factor. So I have told you. So this kind of equations can be very easily solved. For example, if you want an example, you can try that this x square minus 3y square dx plus 2xy dy. This is a kind of homogeneous equation. Why homogeneous? You should check that this is a homogeneous function and this is again a homogeneous function. So you just write dy dx, which is 3y square minus x square divided by 2xy, and if you do the substitution y equals to vx, and if you substitute y equals to vx and substitute here and check whether this equation is transferred to a separable equation. Separable means y part only if the functions of y with dy and the functions of y x are with dx. So at this point it's not separable because you see the dx part has y square in it and dy part has y in it. So sorry, x in it. So somehow we can remove this 2x by dividing this whole thing by 2x, but this part will you can't remove y square so easily. So it's not that easy to remove just by inspection. So you have to do this type of substitution. So by this substitution, you will check or this kind of equation is transferred to a separable equations. So it's for a separable equation, it's very easy. That I have told you how to find that integrating factor. Okay. So now I am going to tell you what is first order ODE, which is linear, and how to solve this equation. First order ODE, that is we take this kind of ODE. You see this is a non-homogeneous kind of thing. It's not homogeneous or non-homogeneous is that I have talked earlier. It's not this homogeneous. This non-homogeneous is arising from that right hand side term. It's not zero. That's why non-homogeneous. So this linear, you see this is a linear equation because there is no product term of y square or y dy dx. This kind of terms are not there. So this is a linear equation, and why is first order? Because you see the highest order is dy dx is 1. So our question is how to solve. So how to solve this kind of equation is actually not that difficult. So what we follow actually, you see, I can write this equation in this manner. Dx. So sorry, it is dx. We just dy dx, that means dy plus pxy dx, and dx that side qx dx, and you just take x. So there is nothing, that means there is y. So you see something a dx plus something dy. So you see, this is a kind of equation of this form: m dx plus n dy is equals to 0. So what is m? M is this thing. What is n? N is basically this thing. So how to solve this kind of equation? This is our task. So this kind of equations, you see, we should check whether it is exact or not. If it is not exact, we will multiply it by integrating factor, and from that integrating, you multiply integrating factor. After multiplying, it will become exact equation, and from that exact equation we will again use the condition of exactness, and from the condition of exactness we will solve the unknown function mu. So this is our point of approach here. So if you I think next page is better. So I think you all know, I am not going into details, but for your purpose, I will a little bit that will be better for you. So we have m equals to this pxy minus qx, n equals to 1. So you will check that this is not exact equation. So what you will do, you just multiply by mu. So now this becomes exact. So now again you will use the condition of exactness, or del m del y, sorry, del m dash del y equals to del n dash x. So you, from this is step 1, this is step 2, this is step 1, and this is step 2. Why? Because from this you will conclude that not exact. You will check, because this kind of equation does not satisfy, the relation doesn't satisfy del m del y equals to del, you will get this kind of thing, del m del y is not del n del x, you will get. So from this you just multiply by this mu, both m and n, and whatever will come we will say as m dash and n dash respectively. Now to check the condition of exactness, and since this mu is integrating factor that we have asked for, so this will be an exact equation, should be. So we are doing it forcefully, and from this relation you just solve mu. What is mu? You will solve it. So basically the solution you will get is nothing but e to the power integration px dx. This will be the solution of mu. So this will be the solution of mu. So this is exactly the integrating factor. Hence integrating factor will be e to the power integration px dx. And if you try to solve this equation, ordinary differential equation, I have told you that you have to find the function capital F, and F equals to C will be the solution, and I have also given an example of how to solve or how to get that function f. This is the way, this is the example. So this way I have told you, in this way you can also get the solution, and the solution will be nothing but this kind of thing. This will be I guess integration ex dx into ux. This is a very standard thing, and this whole thing will be integrated again plus c. So this integrating factor with a minus sign is there, and same integrating factor into qx dx, the whole thing you will again integrate out plus c. So this is the solution of the differential equation. So this is a very complicated thing, you don't have to remember this thing, but you have to remember how to find this mu, or what is the form of mu. Mu equals to integration e to the power integration ex dx. So for an example, you can check this kind of function or this kind of equations. So if you check, in this case ex equals to 2x plus 1 divided by x, and if you try to find out what is mu, I think you will get e to the power 2x. This is mu, this is the integrating factor. You can easily check e to the power integration px dx from this thing. So from this, if you try to multiply this both side, and you will check that this left hand side you can write as in this way. This will become x e to the power 2x dy dx plus e to the power 2x, okay, 2x plus 1. So this thing will be there, and this whole left hand side you can at once write as, you can see, x e to the power 2xy is equals to x. So it's now a trivial task, so you can solve this trivially, and the solution will be like that. X e to the power x y will be nothing but 1 minute. হ্যাঁ বলুন। হ্যাঁ ম্যাডাম 10 মিনিটের মধ্যে পাঠাচ্ছি, ক্লাসটা শেষ করে পাঠাচ্ছি। ঠিক আছে, আমি পাঠিয়ে দিচ্ছি, 10 মিনিট পরে পাঠাচ্ছি। So this is our solution plus c. So this is a very simple solution, or that's how you can solve this thing. So I'm doing it a little bit fast because I have not much time today. So just I want to tell you two or three very important formulas that you need to learn in your course, and these formulas will help you to solve many more problems of actually these problems regarding finding integrating factor of, or finding integrating factor in some situations. So suppose you are given some non-exact equation. So this is m dx plus n dy is equals to 0. Now I will mention two or three points where you can solve this kind of non-exact differential equations very easily. So number one, 1 by m del n del x minus del m del y. So actually you see, if you have integrating factor, you can very easily solve any this kind of differential equation. So the point is finding integrating factor. So this thing, if this thing is a function of y only, say this is phi 1 y. So in this case, this mu one integration e to the power, sorry, no, it's not integration here, but here phi 1 y dy. This is the integration factor in this case. So you are given this kind of differential equation which is non-exact. You just calculate this thing. If this is coming as only a function of y, no x is there. So this is the integration factor of this equation. It's very simple, as simple as that. Again, a very similar kind of thing. This is number 2. You just calculate 1 by n del m del y minus del n del x. So you just calculate this, and this is a function of x. The previously there's a function of y. So now it's coming function of x only. So you see, you say this is a function of x only. So in this case, our integrating factor will be mu2, which is nothing but e to the power integration phi 2x dx. This is integration factor in this case. Okay, so this is number 2. Number 3, suppose m and n, they are both homogeneous function. Homogeneous function of same degree. Same degree means m is a homogeneous function of degree n. This is also homogeneous function of degree n. It can be 2, it can be 3. This can happen. They are both same, of same degree, same homogeneous function of same degree. In this case, this integrating factor will be 1 by mx plus ny. This will be the integrating factor. This is number 3. Number 4, for example, this m function is of this form, f1 xy, and n is x f2. That means m is y into some function of xy. Xy, the function of xy means, suppose x square plus y square plus 1. This kind of function. This is a function of xy. So this x1 if there is no comma, is xy multiplication. So like in this function sin xy, this function of xy. So, and again n is a function x into f2 of xy, function of xy. N is also function of xy multiplied by x, and you have mx minus ny is non-zero. In this case, mu will be 1 by mx minus ny. So these are 4 basic rules. Actually, there are another rule, but no, I'm not mentioning that. It's not for today, or at least in this lecture. So these are very simple ways, or very 4 types of differential equations where we can find the integrating factor very easily. So I can actually mention 1 or 2 problems, like this problem for 2x square plus y. Zero. So if we check, m is equals to 2x square plus y, m dx, n dy, and n is obviously n square y minus x. So you can check if it is exact or not, and you will see that it is not an exact equation. So what you will do, you will find this is 1, and del n del x is equals to 2xy minus 1. So now if you check what is 1 by m del y minus del n del x, you will get, if you just simplify, and you will get minus 2 by x you will get. So this is a function of x only, and what I have told you that this, if this is a function of x only, integrating factor, our integrating factor will be e to the power integration that function, that phi of x. So in this case, what will be our integrating factor? It will be e to the power integration of this thing. So actually it will come as m equals to 1 by x square. So what we will do, we just multiplies out by 1 by x square both side, and you will find the new m dash and n dash, and this new m dash and n dash you can check that they will, this del m dash del y and del n dash del x, they are equal. So it becomes an exact equation, and you know how to solve an exact equation. So this is the very trivial and small thing. And one more thing, and one last thing of today's lecture is what I should mention, that is Bernoulli's equation. Bernoulli's equation is like this type of equations. Bernoulli's equations are this kind of equation. These kind of equations are again a type of differential equations which are easy to solve, or at least this kind of equations can be, if you take some kind of substitution, this type of equations can be solved. So what is the method of solving this kind of differential equation? So if you take y equals to y to the power 1 minus n is v, so if you take this kind of substitution, so you can check. Okay, the first point I have to mention, must that this is a non-linear equation. So because there is power y to the power n is involved. So but this kind of substitution is a very powerful substitution which can reduce these equations to linear equations of this type of form, dv dx plus p1x v equals to q1 x. So you know this is, yeah, you do the substitution. I think you can do this type of substitution. You just find dv dx or dy dx and substitute it here, and make it the function of v and x only. So you will get this kind of functions, and you see this type of function is nothing but the first order linear differential equation which I have solved earlier, or I have told you the integration factor will be nothing but this kind of function, integration e to the power integration p1 x dx. I have told you mu is equal to this and how to solve these equations. So this type of Bernoulli's equation is nothing but a special occasion or special part of this kind of first order ordinary differential equation. It's a special part because they're actually non-linear, but they can be reduced to linear equation, and thus this can be solved. It's a very interesting thing. So Bernoulli's equation, you will I think this type of equations you will encounter. So I am also giving you one problem which you should or you can at least try this type of function. Example, dy dx plus y equals to x y to the power n. So what will be the substitution? Substitution will be 1 minus 3, that is y to the power minus 2. So take this substitution v equals to y to the power minus 2 and reduce this equation of y and x to v and x. So and you will see that the reduced equations will be a linear equation, equation, and from that linear equation you can at once solve these kind of equations. So I think up to this will be enough for initial lecture or introduction on ordinary differential equation, or exactly what is integrating factor and how to find out the integrating factor from a given equation, or also some forms of the integrating factor, or actually some special forms of integrating factor. Actually I have mentioned 4 different kind of way or 4 different ways of finding integration factor of mdx plus ndy equals 0, this kind from this kind of equation. So these 4 formulas I think actually you have to remember, otherwise you can be able to apply this kind of formula. So these 4 formulas are important. So until now you can ask me any problem or any question, whatever you like, from the topics I have covered. So this is actually a very precise introduction to ordinary differential equation and integrating factor. So that's for my extension lecture. So you are free to ask any questions from the topics I have covered. So is there any question? And you should try some of the problems which I have mentioned. I will share the slides, no problem. And from the slides, you just try to understand the formulas and just get used to the formulas and try to solve the problems which I've left or I have given hints only. You try to solve the problems and show to me, and I'll check this. So, is there any problem or any question? Is there any question? You can ask, no problem.
No sir, no problem.
প্রবলেম নেই কারো? আচ্ছা ঠিক আছে, যদি না প্রবলেম থাকে তো আজকে আমরা তাহলে এখানেই আমরা এন্ড করতে পারি, কোনো অসুবিধা নেই। So we can end here. So I request you just try those problems which I have given and show it to me. It will be beneficial for you, because this type of things will recurrently come in your physics, or it will come also in your mathematics, but in physics also, because you have to solve different kinds of problems, some different physical equations. So while solving these equations, you will need to know this type of formulas. Okay. So we can leave for this day, I think. লিভ করতে পারিস, কোনো অসুবিধা নেই তাহলে, যদি কোশ্চেন না থাকে।